Welcome to Calculus 1. Today we're going to talk about what we so-call the chain rules. Okay, this rule is really used to deal with composite functions, and it's one of our most powerful differentiation rules that we have compared to the other ones. Alright, so this is how it goes, and try not to let these notation confuse you because it gets a little bit too hectic. So if we have y is equal to f of u, and y is differentiable function of u, and we say u is equal to another function called g sub x, alright, where g sub x is a differentiable function of x, then y is equal to f of g sub x, which is written as a composite function, is a differentiable function of x. So if I want to take a derivative of y, okay, dy dx, that will equal to derivative of the y, derivative of f of u in respect of u, times derivative of u. Remember now, u is another function, okay, in respect of x. Alright, the easier way to say it, okay, besides just reading the notation, is if I need to take a derivative of a composite function in respect of x, it will equal to the derivative of the outside of the inside times the derivative of the inside function. Okay, derivative of the outside of the inside, you still got to write down the inside function, then times derivative of the inside. Okay, so I will show you how to do this both ways. Okay, but basically both ways saying the same thing. So if I have a function like this one, okay, this is where chain rule comes in. Okay, become very powerful, because without chain rule, normally we can take a derivative of something to some kind of exponent. We can use our power rule, but what happens if this x will be something bigger, okay, something more complicated? Then that's where the chain rule comes in. So I want to show you what this first formula is trying to say. So I'm going to say the inside function is 2x squared plus 1, like u to be the inside function. Okay, if this is a u, if this whole thing 2x squared plus 1 is u, then my y will actually equal to u to the third power. So the outside function is u to the third. The inside function is 2x squared plus 1. So if I want to take a derivative of my y in respect of x, that will equal to dy over du. So let me purposely write it this way. Okay. What that means is dy over du will be, remember now, this whole thing is like a u here. So I'm basically trying to take a derivative, okay, of u to the third power in respect of u. Let me put this in the bracket. Okay, so basically what I'm saying is I'm taking a derivative of my outside function, which is u to the third, times derivative of my u, which is the 2x squared plus 1 in respect of x. So that will be derivative of that 2x squared plus 1 in respect to x. Okay, in the next video, in the next lecture video, you will notice that when we take a derivative, okay, these variables got to agree when we take a derivative. If not, then you will be called the implicit differentiation. Alright, so if I take a derivative of my u to the third, my outside function, that will give me 3u squared times derivative of my inside function, which is my 2x squared plus 1, that will give me 4x. Alright, so now I'm gonna rewrite my u right here as back to my 2x squared plus 1. So that will be 3 times 2x squared plus 1 whole thing squared times the 4x. So 4x times 3 up front will actually tell me the answer is 12x times 2x plus 1 whole thing squared. Okay. Alright, so another way of saying it, okay, which is the way I would normally say it, looking back at this problem, I'm going to put it down here. Alright, so if I want to find the derivative, okay, of this function, I will simply say derivative of the outside. There's third powers on the outside. Okay, derivative of the outside, so that's using a power rule. So that will be 3 times something and minus the exponent, that will be a 2. Derivative of the outside of the inside times the derivative of the inside, which is 4x. Okay, and that's what chain rule is. Derivative of the outside of the inside times derivative of the inside. Okay. Alright. So, problem look like this, okay, can be used as a special case of a chain rule called the general power rule. The general power rule says if I have a function, okay, if I have a function y is equal to u to, a function u in respect of x to some kind of exponent on the outside, where u is differentiable function and my exponent is a rational number, then I can apply the power rule, which is move the exponent to the front then of the inside, and then exponent minus 1 is like using the power rule, and times du over dx. Du over dx is referring to take a derivative of the inside in respect of x. And then to write it a little bit simpler, okay, derivative of the derivative in respect of x of u to the n, okay, that will be move the exponent to the front, exponent minus 1 of u times u prime. U prime is the same thing as this right here, du over dx. Okay, so for other problems later on, I will use that thing called u prime. Alright, so give the same problem, I'm just write it out differently, okay? Alright, so my function f of x, okay, so I'm going to let u, basically if I want to match to this problem, I basically say my u is 2x squared plus 1. Alright, so that means my f of x, my entire function f of x, is basically saying u to the third power. Okay, so if I use my rule here, my f prime of x, okay, is using the formula n times u to the n minus 1 power times u prime. Alright, so move my exponent, okay, to the front, so that'll be 3 times u to the second power times, okay, u prime. U is 2x squared plus 1, so that would be derivative of the u prime in respect of x, that would be 4x. So this thing looks just like a chain rule earlier. Now I just gotta rewrite my u as the 2x squared plus 1, so that would be 3 times 4x, 12x, times u itself is 2x squared plus 1 whole thing to the second power. Okay, and one of the reasons why I want to show you this is kind of let you see there is something called U substitution when we talk about integration. Okay, using this technique a lot. Okay, like U to represent something else, so we can factor it, or we can do integration a lot easier. Alright, so it's basically the same thing as the chain rule here. Okay, so normally when we deal with chain rule, I will simply say derivative of the outside of the inside times derivative of the inside. So let's give that a try. Okay, this is a cube root function here. So the first thing I'm going to do is rewrite this function as 2x squared plus 1 whole thing to the 2/3 power. It's 2/3 power because cube roots, the denominator determines the roots. The numerator too tell you that what's inside this radical is to that power. Alright, so I'm going to rewrite this as a with a fraction exponent. So now when I'm ready to take a derivative in respect of x, the outside will be the 2/3 power. The inside function will be 2x squared plus 1. So derivative of the outside using a power rule tell me that will be 2/3 derivative outside of the inside. And don't forget my exponent will have to subtract 1. 2/3 minus 1 is negative 1/3. And then times derivative of the outside of the inside times derivative of the inside, which is 4x. Okay, just using a power rule and a constant rule. Alright, let's simplify this. 2/3 times 4x, that will be a over 3x, or ax over 3. So this is ax over 3 times 2x squared plus 1 to the negative 1/3 power. Alright, negative exponent, we'll flip it to the bottom of the fraction. Since the 3 is already in the bottom as well, so that means the only thing I have left on top is my ax. Alright, my 3 is still down here. Okay, negative exponent flip down to the bottom, and I convert back to a radical, negative 1/3 power. The negative tell you to flip. The 1/3 power, that tells you it's going to be a cube root. So that's 3 times cube root of 2x squared plus 1. Okay, that will be the simplified answer. Alright. And you will notice sometimes I will rewrite my fraction exponent as back to a radical, or I will just leave it as a fraction exponent in a denominator. Okay, it just depends. Alright, let's try another one. This one here, even though the function is written as a rational function, most of the time we think about this problem as using the quotient rule, but the numerator is only a constant. Okay, so that constant can be factored out. So what I'm going to do is rewrite this problem as a negative 7 times 2x squared minus 3 to the negative 2 power. Okay, so I basically flip what I have in the denominator back to the top. So when I'm ready to take a derivative, okay, the negative 7 will be factored out. So my negative 7 times what stays in the front. Alright, derivative of the outside, so that will be negative 2. Okay, derivative of the outside of the inside. Alright, make sure we subtract 1 from the exponent, that's negative 3, times the derivative of the inside. Derivative of the outside of the inside, then times derivative of the inside, which is 4x. Alright, if I multiply negative 7, negative 2, and my 4x, that will give me 56x. times 2x squared minus 3 to the negative third power. And I'm going to flip this negative third power to the other side of my fractions. So my 56x stays on top over 2x squared minus 3 whole thing to the third power. Okay, and that would be it. 56x, excuse me. Alright, the next example is a little bit tough. So before I do this one, I'm going to show you here something about factoring that we rarely done. If I have maybe like x to the third plus maybe like x to the fourth power, okay, if I want to factor this polynomial, I know I can factor out x to the third. If I factor out x to the third, what would be left is 1 plus x. Okay, so exactly what's going on is when we do factoring, that means we are actually dividing. So my greatest common factor x to the third is trying to go into, okay, my first term, x to the third power. Okay, my greatest common factor is trying to go into x to the third power. So x to the third going to x to the third is 1 time. It's because power rule for the exponent tell me I'm supposed to subtract the exponents. Okay, so when I subtract the exponents, I end up with x to the 0 power, which is just 1. That's why x to the third going to x to the third 1 time. Alright, x to the third going to x to the fourth. So that means x to the fourth is on top. Okay, so again, if I subtract the exponent, that will be 4 minus 3. That will just leave me x to the first power. 4 minus 3 is just 1. Okay, just want to refresh your memory on this. Alright, so let's take a look at this problem. This problem is a little bit more complicated. I'm going to first rewrite my radical here as a fraction exponent. So this is going to be t squared times 1 minus t squared to the half power. Okay, so this problem, t squared is multiplying, so I gotta use a product rule when I do my differentiation, and I'm gonna do a chain rule as well. Alright, so let's go ahead and get started. Try not to write as much. So product rule, derivative of the first times the second product rule is derivative of the first times the second plus the derivative of the second times the first. So I'm going to go ahead and write down my t squared here at the beginning, because I will still end up times the first, which is my t squared. So derivative of the second, alright, using a chain rule, derivative of the outside of the inside, 1/2 minus 1 will be -1/2, then times the derivative of the inside. Derivative of the inside will be -2t. Okay, so let me just kind of highlight this. Alright, so this part is the derivative of the second times the first, okay, from the product rule. Alright, 2t is derivative first times the second plus derivative of the second times the first. Alright, now let's simplify this. Oh, this is a lot. Let's see. -2 times half, and the positive sign here, that will cancel out. Alright, this will be a minus now. Okay, t squared times t to the third power. then I still got 1 minus t squared to the negative half t. Excuse me, to the negative half power. Alright, the front is still 2t times 1 minus t squared to the half power. Alright, let's factor this. Okay, let's clean this up a little bit. I see t and t can be factored out. Okay, this is t to the t to the third, so I know I can factor out a t to the outside. Alright, since I do have 1 minus t squared for both terms, even though their exponents are different, okay, what I can do is factor out 1 minus t squared to the negative half power. Why negative half power? Why negative half power? Because if you remember earlier, when I have x to the third plus x to the third, excuse me, x to the fourth, my greatest common factor was x to the third, because when we factor out the greatest common factor for the exponents, we always choose the smallest one. So negative half power is smaller than the positive half. That's why I factor out the negative half power. Alright, now let's see how this thing works. If I factor out this, then I will times, okay, 2 should be left. Okay, factor out negative half from half. What that means is, what my greatest common factor, something to the negative half power, is trying to go into the same thing with a positive exponent. Okay, my greatest common factor exponent is trying to go into, okay, this half power. So what that means is, my top exponent will subtract the bottom one. So if I subtract a negative half, that will actually give me positive 1 here. So that will be x to the first power, something to the first power. And that something is my 1 minus t squared. So that's 1 minus t squared to the first power. Minus, take a t from t to the third, t squared is left. Take the entire negative half power here to the outside. There's nothing left for my t squared. Okay. Alright, let's simplify the inside. 2 times 1 will be a 2. 2 times negative t squared is negative 2t squared, negative. Let me make sure my signs are correct. Alright, 2 times negative t squared, negative 2t squared, that will be negative 3t squared minus 1 more t squared. So that will be t times 1 minus t squared to the negative half power times 2 minus 3t squared. Negative 2 minus 1, negative 3t squared. Alright, let's simplify this a little bit more. Since this guy has a negative exponent, let me make sure my numbers are right. T is correct. Alright, this guy has negative exponent, so that will go to the bottom. So that will be t times 2 minus 3t squared, the whole thing over 1 minus t squared. Okay. Negative half power come to the bottom, become positive half. Positive half power is the same as the square root. Okay. Alrighty. that's it for that problem. So, problem getting big. Make sure we don't make silly mistakes. And if I do make mistakes, okay, please email me. Let me know, okay, which part of sometimes mission does make mistake. These things gets a little bit big, and I'm trying to write all this stuff with the mouse. Okay, tend to get a little bit crazy. Alrighty, let's do another one. Alright, this one I'm gonna use the same approach as earlier. Okay, I'm gonna bring these guys down here back out to the top. So I'm gonna rewrite this as x times x squared plus 5, okay, to the negative 1/3 power. Okay, cube roots. Okay, so third power, denominator is 3. X squared plus 5 is to the first power in the inside of my radical. It's negative because I brought back to the top. Alright, so this time I'm going to use product rule again. Alright, so this is x is my first. This times all this stuff back here is my second. So derivative of the first times the second plus derivative of the second times the first. So this times the first, I'm going to put it at the beginning, okay? Derivative of the outside of the inside. Derivative of the outside of the inside. And negative 1/3 minus 1 is negative 4/3. Times derivative of the inside, which would just be 2x. Alright, so again, all this stuff here is coming from the chain rule, okay? The derivative of the first times the second plus derivative of the second times the first. So that's why I wrote the x up front. Alright, now let's simplify this. Let's see what I can do on the back side here. Alright, I know this plus sign would become negative. Okay, I know this will become negative here in a minute. X times x is x squared. The first term doesn't have any x outside the parentheses, so I cannot factor that out. So I believe the only thing I can factor out is x squared plus 5 to the negative 4/3 power, because that's a smaller exponent. Alright, times, let's see what's left. If I factor out negative 4/3 from this, that will be x to the negative 4/3, something to the negative 4/3 power, go into the same thing to the negative 1/3 power. So that becomes negative 1/3 minus a negative 4/3. So when we subtract a negative 4/3 here, it becomes plus 4/3. Negative 1 plus 4 is positive 3/3. So that will actually become x to the positive 1 power. Alright, so that means I will have x squared plus 5 to the first power. Now minus, this plus sign become minus. Now I'll come to the iffy part. This half, excuse me, this 1/3 here. Okay, I don't really want the 1/3 here, so what I'm gonna do, okay, between the 1 and the 1/3, I'm gonna factor out a 1/3. Because if I factor out 1/3, that means 1/3 going to 1 will be 3 times. 1/3 going to 1/3 will be 1 time here. Okay, that makes it a little bit easier to work with in the bracket here. Alright, the 2x times x. 2x times x. Two x squared. Alright, this entire thing moved to the outside, so that's why this whole term, okay, which has become x times 2x, which is 2x squared here. Alright, so this minus sign come from this plus sign become negative because of negative right here. So the only thing left for the second term would just simply be x times 2x squared. Alright, if I will simplify inside the bracket, that will be 3x squared minus 2x squared equal to 1x squared. So that will be 1x squared. 3 times positive 5, positive 15. And I still got all these guys up front that I factored out earlier. Alright, so the x squared plus 5 has a negative exponent, so that will got to be flipped. Remember now, this 3 is already in the denominator, so when I flip this negative exponent, it will be right next to the 3 that was already down there as well. So that will be 3 times x squared plus 5 to the positive 4/3 power. Okay, I'm not going to write it back into a radical here. Alright, so the only thing left on top is my x squared plus 15. Okay. Alright, that will be the answer. Alright, one more of these big ones. Then we'll do some smaller problems. Alright, this problem right here. The whole thing is being raised into the second power. Okay, so everybody in here is viewed as the inside function. Okay, so I don't have to rewrite this problem, but be very careful. Okay, Quotient Rule said derivative of the outside of the inside. 3x minus 2. Oops. I didn't mean to put a close parenthesis right there. Let me erase that. Derivative outside of the inside. And this whole thing will be to the first power because 2 minus 1 is 1. Times the derivative of the inside. So the derivative of this inside will actually become a quotient rule. So the quotient rule says the derivative of the top, which is 3, times the bottom, minus the derivative of the bottom, which is 2x, times the top. Then the whole denominator squared. Okay. Alright. Derivative of the outside of the inside times the derivative of the inside. The inside is using a quotient rule, so that will be derivative of the top times the bottom minus the derivative of the bottom times the top. Then divided by denominator, whole thing squared. So let's simplify this top here. Kind of messy. Um, 3x squared minus 6x squared. 3x squared minus 6x squared, that would be negative 3x squared. Alright. 3 times 4 is positive 12. Negative 2x times negative 2, positive 4x. Okay, so that's what's left on the top, okay, of this parenthesis. And this 2 is actually 2 over 1. So this 2 is on the top along with the 3x minus 2 and these guys. So that will be 2 times 3x minus 2. Okay, since I'm multiplying, all my bottom stays in the bottom. So these guys are simplified will still be on the top. 3x minus 2 is on the top, 2 is on the top. X squared plus 4 is in the bottom, along with 2 more x squared plus 4. So that will make it x squared plus 4 to the third power. And I do not think you can factor anything on the top where it will make a difference that will cancel with the bottom. So we will leave the answer like this one. Okay, so that's chain rule. Now a lot of your trigonometric functions, okay, the derivative differentiation of trigonometric functions, okay, is actually using chain rule as well. All right, so we talked about sine and cosine before, but this time I'm writing a slightly different. Okay, after the introduction of chain rule, I don't necessarily have to just take a derivative of a sine x. I can actually take a derivative of sine 2x, things like that. So my inside function is a little bit more than just x now. So that's where the chain rule comes in. So the way I want you to look at it is saying, okay, if I need to take a derivative of sine sine of something in respect of x, the outside function will be the sine. Okay, the inside function will be whatever is here right next to the sine. So derivative of the sine is a cosine. So derivative of the outside of the inside times derivative of the inside. That's why I wrote a u prime right here. Okay. For the cosine will be negative sine. Cosine is the outside function. So derivative of the outside function is negative sine of the inside times the derivative of the inside. Okay. Derivative of the tangent is a secant square of the inside times derivative of the inside. Alright, so this is the cotangent. It will be negative secant square. Secant is secant times tangent. Cosecant will be negative cosecant times cotangent. Okay, so I will keep on referring back to this. What I really want to show you is the inside and outside function. So if you look at this, y equal to sine of 2x, okay, it's basically saying, if I write it just like what I got up there, it's basically saying let your u to become the 2x. So then this problem can be rewritten as y equal to sine of u. So sine of u will be cosine of u times u prime. Cosine of u, so sine of u will be cosine of u, and then times u prime. So 2x, derivative of 2x will just be 2. Alright, so that means my answer will just be 2 times cosine of, what was u? U was 2x. Okay. So that's the way I'm looking at it, but I don't always say it like that. All I see is sine as being an outside function, 2x as the inside function. Okay. So derivative outside is cosine of the inside, which is 2x, times derivative of the inside, 2x is 2. That's it. Alright, check out this one. Okay, so if I want to take a derivative, okay, cosine as being the outside function, derivative of a cosine is negative sine, so that will be derivative of the outside of the inside times the derivative of the inside. Derivative of x minus 2 will just be 1. So this answer will just be negative sine of x minus 2. Okay. Alright, what about cosine of 3x squared? So again, if I put a parenthesis right here, okay, that view, then I can kind of view my cosine as an outside function. Alright, so derivative of a cosine is derivative of the outside, cosine is negative sine. Derivative of the outside of the inside times, okay, I'm going to put this in the parentheses so we won't get confused. Alright, so this is coming from the derivative of the outside times derivative of the inside, which is 6x. I'm not going to put 6x in the parentheses. Alright, so my answer, that would just be negative 6x times sine of 3x squared. There you go. That's all it is. There's a multiplication right here. Alright. Now this one's a little bit tricky because it's cosine squared. So as you can recall in trigonometric courses, cosine squared of something can be rewritten as cosine of, cosine of 3x squared, right? Whole thing being squared, because that square part means I really got cosine times cosine. Cosine times cosine is cosine squared. Alright, so this is a function I'm going to take a derivative of. So my outside is actually the exponent 2. So derivative of the outside of the inside. Okay, this exponent will be 1 times the derivative of the inside. Alright, the derivative of the inside is actually another. Wrong one. The derivative of the inside here is actually composed of cosine and 3x squared. So when I do the derivative of the inside, that means the outside function is cosine. So derivative of the cosine is negative sine. Okay, derivative outside of the inside times the derivative of the inside, which is 6x. Okay. Alright, so back to the top. Okay, at the very beginning, okay, get derivative of the outside of the inside, then times the derivative of this entire inside. Now this inside is actually, cosine is actually the outside function, so we say derivative of the outside, give me this, of the inside times derivative of the actual inside, 6x. Alright, so if I multiply this thing up, my answer will be 12x, negative, there's a negative sign right there, negative 12x times cosine of 3x squared times sine of 3x squared. Okay. Alright, so that's for the trigonometric function. Alright. I mentioned the derivative of e to the x power before. So here I'm writing it down. I'm writing down simply just have an x on one side for these guys, and I'm gonna put a u right there. So remember, derivative of e to the x in respect of x will just be e to the x. After introducing the chain rule, if I need to take a derivative of e to the u in respect of x, that will be e to the u itself again, but I just gotta make sure I times what? U prime right here. Okay. Alright, natural log of x, normally derivative of natural log of x is actually 1 over x. So if I need to take a derivative of a natural log of u in respect of x, that will be 1 over u again. Okay, 1 over whatever this is times the derivative of the inside. So I'm basically viewing the natural log as the outside function, which will give me 1 over whatever, 1 over of the inside, then times derivative of the inside. Okay, basis other than e. Okay, basis other than e. So if my exponent is up here, so normally the derivative of a to the x in respect to x will just be natural log of my base, times itself, a to the x. Alright, if I rewrite it with a u, again that would be natural log of a times itself, and then times u prime. This exponent will be prime. Okay, so I don't want to get too far, just because I want to starting from the top here. So I'm gonna keep on coming back to this. Okay, just kind of show you what the formula is. Alright, so y to the e to the 2x. Okay, y equal e to the 2x. Let me move this up a little bit. So by the formula, e to the 2x, okay, the u is really my 2x. So when I take a derivative, that would just be e to the u, so that means e to the 2x itself times u prime. Since the 2x is the u prime, derivative of 2x will just be 2. So that's why my answer will simply be 2 times e to the 2x power. Okay. Alright, let's look at another one. Let me put it right here. Natural log of 3x. So the 3x is actually the inside function. Okay. Alright, so the natural log of u is 1 over u. So the u is the 3x. So that will be 1 over 3x 1 over u times my u prime. Put them right here. I'm going to say u equal to 3x. Alright, so u prime, derivative of 3x is just going to be 3. So 3 here and the 3 down there canceled out. My answer would just be 1 over x. Alright, that's how you use these formulas on the formula sheet. Alright, let's do something a little bit more complicated. Natural log x times. Okay, so this is a product rule. Alright, so I'm going to write a little bit more. Okay, this for this particular example. So derivative of the first. So that's derivative of x in respect of x. Let me write it this way for a minute. Derivative of the first times the second, which is still natural log of x squared plus 1, plus the derivative of the second. I'm going to write it. Derivative of the second, which is natural log of the x squared plus 1, okay, times the first, which is just x. Okay, so if I write it this way, maybe we can see a little bit better. Alright, derivative of my x would just be 1. So the first term here will still be natural log of x squared plus 1. Alright, a little bit tricky back here. I'm gonna move this x up front of this term. Alright, so remember the u here is the x squared plus 1. So when we take a derivative, a natural log of u will be 1 over u. So that tells me this will be 1 over my u times my u prime. Derivative of my u will be 2x. Alright, so this x is on top, that 2x is on top, x times 2x will make it 2x squared. So this problem would just be natural log of x squared plus 1 plus 2x squared over x squared plus 1. Okay, we can leave it like this, that's fine. Alright, so that was using product rule and the derivative of natural log together. Okay. Now, a little bit more complicated problem. And the reason why this is a little more complicated, because if I rewrite this problem, okay, that will be y equal to natural log of x plus 1 to the 1/3 power. Okay, so this is actually two chain rule putting together. Okay, so two different chain rule put together. It's going to be very, very messy if I would take the derivative of the outside, which is the natural log, which is 1 over this thing. Okay, and then use a chain rule again on this. Okay, that'll be a little bit messy. A little trick that we learned a long time ago: the logarithm of power. Okay, the logarithm of power says the exponent can always be moved to the front. Okay, I don't know if y'all remember that. That was back in module 1. So that allowed me to bring the exponent down. So this problem using the logarithm of power will be 1/3 times natural log of x plus 1. Alright, so the 1/3 become constant while I'm taking a derivative. So my 1/3 stays up front. Alright, derivative of my natural log, the outside function would be 1 over my u, which is x plus 1, times the derivative of my u itself, times derivative of the inside. Derivative of the outside times derivative of the inside, which is another 1. So my problem, the 3 and the x plus 1 in the bottom, so I can say my answer is 1 over 3 times x plus 1. Okay. So a lot of derivative of the outside of the inside times the derivative of the inside. Okay, still the same thing. Alright, so with this problem, I'm gonna use the same trick. Okay, use the same trick. Okay, the sum of the logarithm of sum. Let me just go back. Let me go back and show you some of the module that we talked about. When we talk about logarithm, it's quite long ago. Yeah, remember there was the lecture video 1.10 was kind of long. Well, I'll flip it to it. Okay, all these rules right here. Okay, logarithm of product, logarithm of quotient. So right now I'm going to use the log of quotient. We just used the logarithm of power here. So natural log is a log, so I can do that. Alright, so I'm going to rewrite this. Okay, the division means the top will subtract the bottom. So that would be natural log of x times x squared plus 2 whole thing squared minus the natural log of the bottom. I'm going to go ahead and say that is 2x squared minus 1 to the half power. And the reason why I say half power, because that allows me to move my exponent to the front. So this first term is x times, so that will be addition of a natural log of x plus, go ahead and move my exponent forward, 2 times natural log of x squared plus 2, then minus, move the half forward, half times natural log of 2x squared minus 1. Now this is a little bit easier to differentiate. The natural log of x would simply be 1 over x plus 2 is a constant. So that would be 2 times, okay, derivative of my natural log is 1 over u. U is my x squared plus 2, so that would be 1 over x squared plus 2 times the derivative of the inside, which is 2x, minus half times derivative of the outside will be 1 over my u times the derivative of the inside, which is 4x. Okay, so if I clean this up a little bit, 1 over x, still 1 over x, plus 2 times 2x is 4x over x squared plus 2. Alright, minus the 2 down here and the 4 up here can be reduced into 1 and 2. So that leaves me with 2x on top over 2x squared minus 1 in the bottom. Excuse me. Alright, that will be it for that problem. Excuse me. Alright, let me bring these guys back again. I'm gonna copy and paste it. Alright, let's deal with dealing with bases other than e here. We'll post this. Oops. Alright, so, oh no, there's not. These guys got the wrong one right here. So rather than me flipping back and forth, I'm just gonna do it like this. Alright, so bases other than e. Alright, a to the u power. So my u is 4x here. So when I take a derivative, okay, that will be natural log of my base, so the natural log of 2 times a to the u, that means itself here, 2 to the 4x, then times derivative of u prime, and u prime was the 4x. Derivative of 4x is just going to be 4. Alright, so don't go crazy now. Literally take the 4 times the 2 because the exponents are different. You can't multiply them. So instead, natural log of 2 is a constant. So we're gonna put the constant part together. So that will be 4 times natural log of 2. And then I'm gonna say times, so this is a constant, times base 2 to the 4x. Okay, we'll write it like that. And I can put this in the parenthesis right here just to show you that that's the constant part of the answer. Alright, derivative of a logarithm. Okay, derivative of log with the base a of u is 1 over natural log of the base, okay, times u itself times u prime. So here my u is actually my cosine of x. So my u is cosine of x. Alright, so my derivative will be 1 over natural log of my base. Natural log of my base is 2 times my u down here along with natural log of a. My u is cosine of x, then times outside the fraction u prime. Cosine of x, I believe, was negative sine x. So this negative sine x is actually going to be over 1, so that makes it on the top. So if I simplify this, that will be negative sine x over natural log of 2 times cosine of x. Alright, and I remember in one of these videos I mentioned something about be careful with the trig functions where these trig identities, okay, can pop out inside our final answer for the derivative. So now sine x over cosine x is actually tangent. So my final answer is actually need to be negative tangent of x over natural log of 2. Okay, that's the reason why you also have a trigonometry part. Okay, in your with your formula sheet. Okay. All right, one more. This problem. One more. This one is just a little bit more complicated than the previous one. So I'm going to use the same trick as we did earlier. Okay, this is log of quotient, so I'm going to simplify it by saying the division going to be the subtraction here. The square root is a half power, so I'm moving my half forward. Log with a base 3 of x minus log with a base 3 of x plus 7. Okay, so if I want, so when I take a derivative, this is basically derivative of the difference. Okay, so derivative of the first minus the derivative of the second. Derivative of the first, half stays as a half, time derivative of a log base 3 of x. That will be 1 over natural log of my base times my u times u prime. 1 over natural log of my base 3 times my u, which is my x, times u prime. Derivative of x is 1, so I'm not even going to write it. I'm going to put my natural log of 3 in the parenthesis, so you won't say that's 3x. Alright, minus, alright, 1 over natural log over my base, alright, times my u, which is the entire x plus 7, times the derivative of my u, which is 1 again. I'm not even going to write it. Okay, so here we go. Alright, now let's clean this up a little bit. This is a little bit messy. This 2 times 1 over, so this 2 is along with that natural log. Alright, so basically what I got here is 1 over 2 times natural log of 3 x minus 1 over natural log of 3 of x plus 7. Now since I got natural log of 3 flying everywhere here, I'm gonna go ahead and simplify this a little bit further down. Okay, my LCD, count the repeated factors in the denominator and the non-repeated. So 2 natural log of 3 is in both the denominator. 2 was not in both, but you still gotta count the non-repeated ones, times x times x plus 7. Okay, so this is my LCD. Now I'm gonna write a little bit neater. It'll be 2 times natural log of 3. I'm gonna put x right here because natural log of 3 times 2 is a constant, times x plus 7. Alright, so 2 natural log of 3x go into my LCD. Okay, we will increase x plus 7 times. So a lot of time I teach students to look at the difference in the denominator. What does the LCD have that the first denominator do not have, which is x plus 7. So we take the x plus 7 and minus what does the LCD has that the second denominator do not have, a 2 and an x. So that'll be 2x. So my final answer, x minus 2x, is negative x plus 7 over my entire LCD. Alright. So hopefully after this lecture video you can see how powerful this chain rule is, okay, how much chain rule can expand into other types of functions as well. Alright, that will conclude this video.